Welcome back, everybody, for another deep dive. This time, we're going to be looking at something that could really change how we think about AI, and especially machine learning.
It really could.
Yeah, we're diving into a research paper, and it's all about,
Memory layers at scale.
yeah, memory layers at scale. And, just from the title, you can kind of guess we're talking some seriously large-scale AI, right?
Oh, yeah. Huge models, billions of parameters,
Billions.
trained on just an insane amount of data.
Yeah, it really is wild. So before we kind of get lost in like the sheer size of it all,
Sure.
can you maybe just set the stage a little bit? What are memory layers and like why are they such a big deal?
Okay. Well, you have to kind of picture what's happening inside these massive AI models. Okay.
Okay.
So imagine this, like giant interconnected web of information,
Okay.
almost like a brain, but like made of digital connections.
Okay.
So these connections, we call them weights. It's basically how traditional large language models store information.
Oh.
It's a powerful approach,
Mm.
but it has a really major drawback.
Which is,
It's that as these models get bigger, they just become incredibly computationally expensive to train and even just to run.
yeah, I mean, it's kind of like, I don't know, trying to power a city using only AA batteries.
That's a good analogy.
Yeah.
Not very practical.
No, not at all. So it sounds like it's not just about making AI models bigger, it's about making them like smarter and more efficient too, right?
Exactly. And that's where these memory layers come in.
Ooh, okay.
So think of them like a massive, well-organized library, but for AI.
Okay.
Instead of like cramming all this information into this dense network of connections, memory layers store it in a way that's much easier to access and retrieve.
Okay, so instead of like trying to find a single grain of sand on the beach, it's more like having, a neatly labeled container for each grain.
Perfect analogy, yeah.
Mm.
So with memory layers, information is stored kind of like books on a shelf. Each book has a unique identifier, like a key you can use to find it. And when the AI needs to access a specific piece of information, it uses this key value lookup mechanism.
Okay.
It's basically like having like a super fast librarian who can instantly locate any book that you need.
Oh, that sounds amazingly efficient, but like, how does this actually work on such a massive scale?
Right.
Managing a library with like billions of books seems like an impossible task, even for AI.
You're not wrong. It's definitely not easy. Scaling up memory layers to work with these giant models is a huge undertaking. The researchers who wrote this paper, they had to come up with some incredibly clever solutions.
What did they do?
Well, one of the biggest innovations they introduced is something called product key lookup.
Okay.
And what that does is it allows the AI to search through, millions and millions of keys without having to actually compare the query to every single one.
So it's not just like brute force searching through every single entry.
No, no, no. Product key lookup is much more sophisticated than that. It's more like, think of it like a multi-level catalog system. It narrows down the search with each step,
Okay.
almost like having a Dewey Decimal System for AI. And this makes searching incredibly efficient, even with just like this insane amount of information.
So we've got the efficient searching part down, but what about like managing all that data across multiple processing units? I mean, these models are so big, they often have to be split up across several GPUs, right?
Yeah, that's true. And that's another challenge the researchers tackled. What they use is a combination of parallel memory and shared memory techniques.
Okay.
What that does is it helps to kind of distribute the memory load and make sure it's accessible to different parts of the model.
So it's like instead of having one librarian trying to manage this impossibly huge library,
Right.
you have a whole team of specialized librarians working in sync, each responsible for a different section.
Exactly. Great analogy.
And they can find, whatever you need, like instantly.
Pretty much.
Yeah.
But, the other thing they ran into is that a lot of the existing memory layer implementations were actually, like, pretty inefficient.
Oh, really?
Yeah, they found all these like bottlenecks in the code and the retrieval process, stuff like that. So they had to go back and do a bunch of optimizing to make everything run smoothly and efficiently.
So they like upgraded the library's infrastructure, got rid of the creaky old bookshelves, and put in like state-of-the-art, super fast conveyor belts.
Exactly. So now it's not just efficient, it's incredibly fast too.
Wow. So they've basically like supercharged these memory layers. But I bet our listeners wondering right now, like, what does all this technical wizardry actually mean for, real world applications? What are the benefits?
That's the exciting part. The researchers found that models that used these supercharged memory layers, they showed like this remarkable improvement in accuracy,
Really?
especially when it came to answering questions based on factual knowledge.
So it's not just about being fast, it's about being right too.
Exactly. We're talking over a 100% improvement on some benchmarks.
Whoa, over 100%. So
Mm,
it's like the difference between an AI that's kind of like barely scraping by and one that's like acing every test.
exactly. And that improvement in accuracy is huge for things like chatbots, virtual assistants, research tools, even educational platforms,
Right.
anything where you need reliable information.
Yeah. It's almost like having I don't know, like a walking, talking encyclopedia that's always up to date and never makes mistakes.
That's a great way to put it.
But okay, so we've talked a lot about memory layers. Are there other approaches out there for improving AI efficiency? Like how do memory layers stack up against the competition?
Yeah, good question. There are definitely other techniques, things like mixture of experts, we call it MOE,
Mm-hmm.
where you essentially have like different AI specialists for different tasks.
Okay.
And then there's peer,
Mm-hmm.
which is like kind of a network that's constantly rewiring itself to adapt to different problems.
So it's like having a team of AI specialists or like a super adaptable neural network.
Right.
But how did those do compared to memory layers?
Well, they did the head-to-head comparisons and memory layers, just they outperformed both MOE and peer,
Yeah.
especially on tasks that involve like, digging up factual information.
Interesting. So it's not just efficient, it's like the best.
Pretty much.
Wow.
Yeah.
Okay, so they're efficient, they're accurate, they outperform the other approaches. Do they give any specific examples in the paper of just how much more efficient memory layers are compared to like the traditional models?
Oh, yeah, they do. They had one example that really stood out. It was a model with a 1.3 billion parameter base
Yeah.
and 64 million keys.
Oh.
And it achieved basically the same performance as a much larger model that was trained using like 10 times more computing power.
10 times. So
Yeah.
same result, but with a fraction of the effort? That's incredible.
It is. It's pretty remarkable.
Yeah.
And, it really highlights how memory layers have this potential to make AI more accessible, less resource intensive.
Yeah, no, that's huge. I mean, not everyone has access to, giant supercomputers. This could really democratize AI development in a way. But before we get too far ahead of ourselves, I know our listeners are probably wondering what comes next.
Right.
What's next for these memory layers and what possibilities do they open up? And we will get into all of that
For sure.
after a quick break.
So one of the things that's really fascinating about this research is that it kind of hints at this possibility of continuous learning in AI.
Oh, wow, okay. That sounds pretty sci-fi. What do you mean by continuous learning? Like, what does that even look like?
Well, think about how we learn as humans,
Yeah.
right? We're always taking in new information, adding to what we already know,
Mm-hmm.
without necessarily forgetting the old stuff.
You know, most of the time, at least. Unless it's like, where I put my keys.
Right, haha. But for AI, that kind of continuous learning has been a real challenge.
Really? Why is that?
Well, traditional AI models, they have this tendency to just kind of overwrite old information with new data. And that's not exactly ideal if you want an AI that can actually like learn and grow over time, right?
No, not at all. So are you saying that these memory layers, they could be like the solution to AI's forgetfulness problem?
That's the hope. The idea is that instead of like cramming everything into the model's weights, which can be overwritten,
Right.
you have this separate, well-organized memory bank that can just be constantly updated and expanded with new information. It's almost like, I don't know, having a dedicated space for new knowledge so you don't have to erase what's already in your brain.
So it's like, instead of having to like throw out old files to make room for new ones, you just get a bigger filing cabinet.
Exactly. And because the memory layer is so good at retrieving information, the AI can access both the old and new stuff seamlessly. It can actually learn and adapt continuously without losing what it already understood.
That's pretty amazing. But I gotta admit, all this talk about like managing this ever-growing memory bank, it makes me wonder about the complexity. Wouldn't it be like incredibly difficult to keep all that information organized, especially as it grows and grows?
It's definitely a valid concern, and it's something that, researchers are actively working on.
Okay.
But remember, the memory layer itself is designed to be really efficient and scalable.
Right.
And with those techniques we were talking about before, like product key lookup and parallel memory, managing all that data, it becomes a lot more feasible.
So it's a challenge, but not an impossible one.
Right. And I think, our listeners are probably already starting to imagine all the possibilities that this opens up.
I mean, I know I am.
Right. It's huge. Think
Yeah.
about it. Like AI assistants that can remember every interaction they've ever had with you and tailor their responses based on, your needs and your
Yeah.
preferences. Or imagine researchers being able to train AI models on like these constantly evolving data sets, keeping them up to date with the latest info without having to start from scratch every time.
Yeah. No more AI telling me that the Earth is flat or that Elvis is still alive.
Uh-huh. Exactly. With memory layers, chatbots could actually like access this vast database of factual information and give you reliable answers. And that would be a game changer for customer service, education, even just casual conversation.
It's like having a walking, talking encyclopedia in your pocket.
Exactly.
Okay, but let's say you want to do something a little more creative, like, I don't know, writing a story or composing music.
Yeah.
Could memory layers help with that too?
That's an interesting question. And to be honest, this particular research paper didn't really delve into that too deeply.
Okay.
But, I think it's definitely possible that memory layers could help with tasks that require a lot of factual grounding. So, like, imagine generating stories that are historically accurate
Mm.
or creating artwork that's based on specific cultural references, things like that.
So it could be like giving AI a much deeper understanding of the world so it can actually create stuff that's more meaningful and informed.
Right, exactly. But like you said, I think there's still a lot we don't know about how memory layers would interact with those, like, more creative aspects of AI.
Yeah, that makes sense. It definitely seems like an area ripe for future research.
Oh, absolutely.
But okay, so for now, let's zoom back out a little bit and think about the bigger picture. How could memory layers change the way AI is developed overall?
Well, if they turn out to be as effective as this research suggests,
Right.
they could really lead to a pretty fundamental shift in how we think about building and training these AI models.
How so?
Well, instead of just focusing on making models bigger and bigger, we might start to prioritize making them smarter and more efficient.
Right. So it's not about brute force. It's about more elegant solutions.
Exactly. Memory layers give us a way to achieve high performance without the massive computational costs that come with like traditional large language models.
And that could be huge for making AI development more accessible to a wider range of researchers and organizations.
Absolutely. Democratizing AI in a way.
That's really exciting. But, are there any potential downsides to this kind of shift? Like anything we should be wary of?
Well, it's important to remember that, any technological advancement comes with its own set of considerations.
Sure.
If AI models become really reliant on memory layers,
Right.
we have to be super careful about what information is stored in them and how it's used.
So things like data security and responsible AI development, they become even more important.
Absolutely. We need to make sure that the information in those memory layers is accurate, that it's unbiased, and that it's used ethically.
Right, of course.
And we need to develop ways to protect user privacy and prevent this information from being misused.
That's a really good point. As AI continues to advance, we can't lose sight of those ethical considerations.
Agreed.
Well, it seems like we've covered a lot of ground today, but before we wrap things up, let's just take a minute to recap some of the key insights for our listener.
Sure. So the big takeaway here is that memory layers offer a really promising new approach to building AI models. Not only are they more powerful, but they're also more efficient and potentially even capable of this continuous learning thing we were talking about.
Right. It's not just about size anymore. It's about building AI that's, smarter and more adaptable.
Exactly. And while there are definitely still some challenges to overcome, the potential benefits are they're huge.
Yeah. It's really exciting stuff.
It is. This research really suggests that memory layers could completely change the way we build, train, and even just like interact with these intelligent systems in the future.
Absolutely. Okay, well, on that note, I think it's time for us to move on to the final part of our deep dive. Okay, so we've talked about all the great things about memory layers, the possibilities, the challenges, all that. But
Yeah.
where does this leave us? What's the takeaway for our listeners? Like, why should they care about all of this?
I think the most exciting thing about this research is that it really points to this potential for a paradigm shift
Mm.
in how we approach AI development.
Okay, yeah, I like that. A paradigm shift.
Yeah.
Can you unpack that a little bit? What do you mean by that?
Well, for years now, the main focus in AI has been on just like scaling things up,
Mm.
making these models bigger and bigger.
Bigger is better.
Yeah, bigger is better. That was the
Mhm.
thinking,
Right.
to try to get better performance.
Right.
But, as we've been talking about that approach, it's kind of hitting a wall.
It's running into some limitations.
Yeah, it's expensive.
Yeah.
It's energy intensive.
And it doesn't necessarily make the AI any smarter.
Exactly.
Yeah.
Exactly. It's like, thinking you can solve every problem with a bigger hammer.
Right?
Sometimes you need a more elegant tool,
And scalpel instead of hammer.
Yeah, exactly. And memory layers, they offer that elegance.
Okay.
They give us this way to add just huge amounts of knowledge to these AI models,
Right.
but without the usual computational overhead.
So it's about making AI more knowledgeable,
Right.
not just bigger. This almost sounds like a return to symbolic AI, but with like a modern twist. You know what I mean?
That's a great point. Yeah, it's like combining the best of both worlds, right?
Yes.
You have the vast knowledge representation of symbolic AI, but with the learning capabilities of modern neural networks.
It's really interesting. It feels like we're like right on the edge of this major transformation
Yeah.
in how we think about and build AI.
I think so. Yeah.
But like, what would that actually look like in practice? Like, how would that change things?
Well, imagine a world where AI isn't just this static piece of software,
Right.
but it's constantly learning and evolving, just like we do.
Yeah.
So instead of being these fixed entities, these models become more like dynamic systems, constantly taking in new information, refining their understanding,
Right.
becoming more knowledgeable over time.
Wow, that's a powerful image. AI, that's like truly alive and learning.
Yep.
But how do we actually get from where we are now to that kind of future? Like, what are the next steps on that path?
Well, there's definitely a lot more research that needs to be done,
Of course.
especially in developing these learning algorithms that are specifically designed for these memory augmented models.
Okay.
So we need algorithms that can handle continuous learning,
Right.
but without running into that catastrophic forgetting issue that we talked about earlier.
Right. So they have to be able to integrate the new information without just like wiping out the old stuff.
Exactly.
Yeah.
Exactly. And we also need algorithms that can help to detect and correct any biases in the information that's stored in the memory layer.
Right. Of course.
And then obviously we need to, make sure that all of that data is secure and private.
Right. We can't forget about the ethical implications.
Absolutely, yeah. So, yeah, there's still a lot of work to be done,
Yeah.
but it's an incredibly exciting area of research.
It sounds like it. It's like a whole new frontier is opening up.
Yeah, it really is. And it has so much potential to really transform, almost every aspect of our lives. If we can figure out how to unlock the full power of this continuous learning in AI.
Okay, my mind is officially blown. But before we go,
Yeah.
I want to leave our listeners with something to think about, something to ponder that goes a little bit beyond what we've already discussed.
Okay, I like that.
So we talked a lot about memory layers and storing, factual information.
Right.
But could they be used to store other types of knowledge as well?
That's a really interesting question.
I mean, you think about like all the different ways that humans know things, right?
Yeah.
It's not just about facts and figures.
No, not at all.
There's procedural knowledge, like knowing how to do things. There's
Right.
emotional intelligence, understanding and responding to feelings.
Yeah. And then there's, social knowledge, like all the unspoken rules and the subtle cues that govern how we interact with each other.
It's like the art of being human.
Exactly.
Yeah.
So could memory layers, could they capture these more, I don't know, these more nuanced, less quantifiable forms of knowledge?
That's the big question. And honestly, I don't think anyone has a good answer to that yet. But
Yeah.
it's definitely something worth thinking about as we move into this new era of AI development.
I love it. What a great question to end on, a challenge to our listeners to keep exploring these ideas.
Exactly.
Well, thank you so much for joining us for this deep dive into the world of memory layers.
It's been a pleasure being here.
It's been fantastic having you. And to all of our listener out there, keep those minds curious, and until next time, happy diving.
Happy diving.